AI can generate financial transactions, but generation is not enforcement. A hallucinated route, stale code, or compromised front-end can still create an unsafe transaction. Aegis turns plain English DeFi goals into guarded Sui transactions, checked before signing and enforced on-chain. The flow has four stages: describe an intent, calculate deterministic risk from live DeepBook data, preview the programmable transaction block, and execute atomically with an on-chain receipt. OpenAI parses and explains it cannot choose package IDs, pool IDs, risk verdicts, or execution rules. This is my Guardian policy, a user-owned Sui Move object. It restricts transaction amount, slippage, allowed DeepBook pool, expiration, ownership, and revocation. These rules are enforced by the Move VM. Bypassing the front end does not bypass the policy. I'll request a swap using ordinary language. For this DeepBook testnet market, Aegis maps the familiar USDC name to DB USDC. OpenAI converts the request into a strictly validated intent containing the assets, amount, maximum slippage, and risk tolerance. The Guardian now reads the live DeepBook order book and calculates four deterministic risk classes: price impact, liquidity depth, market spread, and freshness. The AI may explain these results, but it cannot alter the scores or verdict. The market checks are clear, but explicit confirmation is still required. Before any signature, Aegis shows the exact execution plan: policy, pool, expected output, protected minimum output, deep fee budget, and snapshot time. The three logical atomic stages are policy assertion, deep book swap, and intent receipt mint. The exact PTB has already been dry run against Sui Testnet. Every execution requires explicit confirmation. Nothing signs or executes silently. One wallet signature now submits one atomic PTB. If policy assertion, swap, or receipt creation fails, the entire transaction reverts. This is the real testnet transaction. The first stage asserts the Guardian policy. The second executes the deep book swap. The final stage mints the receipt and emits the intent executed event. All stages were executed in the same programmable transaction block. The result is an owned intent receipt object containing the policy, pool, direction, input, protected, minimum output, risk score, verdict, executor, and timestamp. It is on-chain proof, not a database record. Stress mode uses clearly labeled deterministic demonstration snapshots. It is intentionally non-executable and lets us demonstrate risk conditions safely. This warning exposes elevated risk across the same Guardian classes. Even after acknowledgement, stress mode cannot execute. Sui's object model gives every user an owned and inspectable policy. Move enforces its rules, while PTBs combine policy verification, deep book execution, and receipt creation atomically. This makes the AI useful for understanding intent without giving it authority over execution. Aegis is guarded intent execution on Sui. Plain English goals, deterministic risk, explicit confirmation, and verifiable on-chain proof. The live product, source code, and testnet transactions are linked below.